So the key here is looking at our data and seeing, is it normal distribution? The reason for that is that if it is, we can do some assessment based on that property. There is no real science involved here, although there are some tests that give indications of some data's alignment with the normal distribution. It really overall is a judgment call, and so you need to look at all the data together to see whether or not it can qualify as normal data. So we've got about 7 things that we're actually going to do to look at a set of data and determine whether or not it is normally distributed. The first thing to do is actually graphical, to look at some chart and graphs. 2 things that we do is to look at a stem and leaf diagram. So does this data, when it's drawn in this stem and leaf, appear bell-shaped? And if so, that is an indication of its normalcy. And then the next task is to look at the box and whisker plot, and is that asymmetric? Is there as much to the right as there is to the left? This works really well with small data sets, and if you want small, maybe n less than or equal to 100. Certainly if we get thousands and thousands of data points, drawing them out in the manner of a stem and leaf diagram can get a little repetitive. But for greater than less than 100 data sets, it works out pretty well. Now we're going to come to a minute and see actually what this stem and leaf and box and whiskers are after we go through the 7 tests that we actually want to do. The next couple tests actually look at the vocabulary words that we've taken on, and they are looking at the mean, median, and mode, and are they roughly about the same? Is our data symmetric? That's really what that's saying, because we know if it's skewed, the mean and median aren't going to line up necessarily. The next point for evaluating normalcy is looking at the interquartile range. This is the difference between Q3 and Q1, and is that range equal to approximately 1 1/3 times the sample standard deviation? If it is, that's an indication of normalcy, and if it's much different than that, then our data is not normally distributed. Finally, the last data point, and again this one is, I'd be really careful about, it looks at this whole topic of range, and is the range approximately 6 times the sample standard deviation? What this goes into is looking at the amount of data that falls under the normal distribution curve based on the standard deviation. And by 6 standard deviations, we should have absolutely all of the data collected and accounted for. So a couple visual and a couple number crunching numeric. 2 more to go to look at whether or not some data is normally distributed. The first is looking at the distribution of the data set. Here, we're going to specifically dig into the data and see within 1 standard deviation, do we get about 68% of the observations. Within 2 standard deviations, are we getting 95%, and 3 standard deviations, 99.7%. Obviously, what we're doing here is looking at the area under the curve, and we know for normally distributed within 1 standard deviation, we're at 68%, and it grows from there. That's our 6th data point, and then finally, we evaluate the normal probability plot. We're going to look at the distribution, and if it's linear, we can go ahead and say that that has indication of being normally distributed. Now, to get into the heart of some of these techniques, the first graphic one is the stem and leaf. It's actually quite simple. Giving our data points here for our sample space, what we're going to do is call the first value, in this case the tens power, is going to be our stem, and then anything after that, the ones value, are going to be the leaves. So like before, we've gone ahead and ranked our data from lowest to highest, and then can go ahead and now plot out For our 2s, we've got 21, 24, 24, 26, 27, 27. The key thing is that you're going to line up this data in columns so that you're beginning to build, if it is normally distributed, a stem and leaf diagram that has the normal distribution. Clearly we can say from this data set, because we don't have any small values, medium, small, as far as the number in the leaves, that this probably isn't a normal distribution. So that's our first thing of the stem and leaf diagram. Now we go to the box and whisker plot. Very useful for seeing where our data is spread out to. It's all based upon actually the median of the data itself. So that is the middle of our box, and then we indicate on the right hand side the Q3 data, and on the left hand side this would be the Q1 data. As far as units, say if we're doing our average salary, the units on Q3 and Q1 would be the same as on the median, so the amount of dollars that someone could be paid. The other thing that we go ahead and include on the box and whiskers is looking at both the maximum and the minimum. Within this range, from our Q3 to our maximum data, is the last quartile of data, 25% there, and then obviously at the other end from our smallest bit of data to our Q1 is the lowest 25% of our data that's collected in there. As we look at the box and whisker, it really gives a condensed version of our distribution of the data. Starting with the symmetric, we know that the median and the mean are the same, and so our median is right there. The Q3 and Q1 are going to be equally spaced from that mean/median, and then the range is again symmetric. If we look at our right skewed, in this case we have the mean being near the crest. The Q1 data is going to be, a lot of data is going to be captured in this first quadrant, and so we're going to have a rather narrow window for our right skewed data, because that's where it is in the probability distribution function as we go ahead and plot that. Similarly, for the left skewed, we have that same case where a lot of data comes over a short period of what happens in these cases is that the data between the median and the next quartile, in this case Q2 to Q3, is very tight, and then so we have a small window from Q3 on out to the maximum data. Similarly, on the right skewed, our Q1, Q2 quartile is pretty tight. Little bit of area from the minimum to Q1, big area out here from Q3 to our maximum. So the box and whiskers really show the relationship between our distribution and then a graphic representation. So obviously, the closer that we come to something that looks like the symmetric data, the symmetric box and whisker, that's going to be a better indication that we have normally distributed data.